Okay, today's lesson is 7.2. We're going to solve systems of equations by substitution. So previously we solved them by the graphing method. We graphed the lines that went with both equations to see where they intersected, and that point of intersection was the solution to the equation. Well, now we're going to do the same thing but just a different method. We're going to do it without graphing. So say for instance we have two equations, and one is x is equal to 4y and the other is 4x minus y is equal to 75. Then how can we use substitution to determine what x and y are? So the first thing that you're going to look for when you look at your two equations is there one that I could easily substitute into the other? And when we think about that, we would see that this would be a perfect one. If x is equal to 4y, then we could replace x in the second equation with 4y because x is the same as 4y. So when we do that, when we make that substitution, we would have 4 times 4y minus y is equal to 75. And then go ahead and simplify and combine like terms and all of that. So 4 times 4 is 16. So we have 16y minus y is equal to 75. 16y minus 1y would be 15y is equal to 75. And if we divided both sides by 15, we would find out that y is equal to 5. Okay, so once again, what we did is we substituted this 4y here. Since x is equal to 4y, we substituted 4y for x right here into this equation, and then we were able to solve for y. Okay, well, our goal is at the end to get an ordered pair. So we don't have an ordered pair yet, we just have our y value. So we'll take the y is equal to 5 and then plug it back into this first equation to help us find out what x is. Okay, so take this and then plug it into here to determine our x. So if we do that, x is equal to 4 times 5, which is 20. So x is equal to 20, y is equal to 5. Writing that as an ordered pair, we have 20 comma 5 for our final solution. So that is what we were looking for. Okay, and we'll do another example. Okay, in this example, it's not going to be quite as straightforward about what we need to do. We might have to manipulate one or more of the equations in order to plug that into the second one. So in this example, we'll have 4x plus y is equal to 12. And then we'll have negative 2x minus 3y is equal to 14. So those are our two original equations. So we're looking for a way that we can use substitution to find out our x and y values. So as we look at this, I think we should look at each term and kind of try to figure out where we need to go from here. To solve for x here would be a little tricky. To solve for y here would actually be pretty easy. All we would have to do to solve for y would be to subtract 4x from both sides of the equation. So I think that would be a good place to start. So what we'll do is we will manipulate this equation, subtract 4x from both sides to get y is equal to a negative 4x plus 12. Okay, and then that would be easy to plug this in for y in this equation. So we're going to take all of this, because y is equal to all of this, we'll take that term and plug it in right there in for y. So let's do that now. We'll take negative 2x minus 3 times negative 4x plus 12 is equal to 14. Okay, so where did we get this 4x plus 12 from? That came from right here, because that's equal to y. So when we take negative 3 times y, That's the same thing as negative 3 times negative 4x plus 12. Okay, if we continue to work this problem out, we have to do some distributive property here. It might be a really good idea to change this to adding a negative, and then say negative 3 times negative 4 is a positive 12x. Negative 3 times a positive 12 is a negative 36, and that's equal to 14. Combine like terms, we get 10x minus 36 equals 14. Add 36 to both sides, and we get 10x is equal to 50. Divide both sides by 10, and we end up with the result is x is equal to 5. And once again, just like before, we're not done. That gives us x. We still have to find y. So we want to plug this 5, x is equal to 5, up here in this equation. Okay, substitute 5 in here, and then we'll be able to figure out what y is. So let's do that. We have y is equal to negative 4 times 5 plus 12. So negative 4 times 5 is a negative 20 plus 12. That means y is equal to negative 8. Okay, so our ordered pair is 5 comma negative 8. So there you go. There's our final answer. There's our solution. That is the only ordered pair that will satisfy both of these original equations, and that's what we're going for. We're looking for an ordered pair that will satisfy both of the equations and make both of them true. And you could always substitute 5 into the equation for x and negative 8 into either of these equations for y, and you would find out that your left and right side would be equal to one another, and it checks and it works. The last thing that I want to talk about is just a couple of special cases. Say you're working out the problems and you end up with, at the end when you're trying to solve for your first variable, you end up with, negative 2 is equal to negative 2. In other words, the variables drop out. The variable goes away. And what happens if you end up with a true statement? Well, same thing that kind of happened to us before. This means that there are infinitely many solutions to this. Okay, and really what it means is that you have basically the same line. Okay, it turned out that your two equations that you used were actually equations for the same line. So if you end up with a true statement at the end, you have infinitely many solutions. If you end up with a false statement at the end, like negative 2 is equal to 0, well, obviously we know that's not right, okay? And that would be a case of where there would be no solution. And what this would mean is that your two lines were parallel lines, that they didn't intersect anywhere at any point. So that's why it doesn't work out. There is no solution. It's because they never intersect. So those are a couple of things that could happen, and if you run into those two special cases, that's what it means when you're solving these problems. So we'll do a little bit of practice in class, and then we should be good to go.